Good morning, class. So I decided to add this formula page from the grade 12 note, and these are the identities that we're going to use in grade 11. And so just focus on these three. Sometimes it's easier when you have a formula page to go along with it, right? And so when we are trying to identify where this is coming from, well, we're familiar with the reciprocal identities, which is another way of saying the secondary trig ratios, right? We had cosecant equal 1 over sine x, secant equal 1 over cosine x, and cotangent equal 1 over tan x. So the quotient identity and Pythagorean identities, the way it comes from is the fact if you have, let's say, the tan x, since tan x is equal to what? It's equal to y over x. It's the slope, right? And we notice that for a unit circle that cos theta is equal to x and sine theta is equal to y. So that's when we're working with the unit circle. If that's true, then tan theta is equal to sine theta over cos theta. While for cotangent, it's a similar logic. Cotangent is equal to 1 over tan theta. And what is tan theta equal to? Well, tan theta is equal to y over x, or in this case, x over y, and therefore cos theta divided by sine theta. For the basis of this, y is sine squared x plus cos squared x equal to 1. Well, recall that you have x squared plus y squared equals r squared when we draw a right angle triangle within a circle. And if r is equal to 1, then r squared is going to equal to 1 as well. And so we have x squared plus y squared is equal to 1. And that's what we're working with. So given that we were working with x equals cos theta and y equals sine theta, when dealing with a unit circle, then according to this, well, if I sub cos theta into this and sine theta into this, the proper form of how I write this down is by writing cos theta, I should write cos theta, cos squared theta plus sine 2 theta equals 1. It's important that you do not write it like cos theta squared plus sine theta squared. When we have this implies that the 2 is both on the cos and theta, like it's on the whole thing, and it's as if we have brackets. Though this would be bad form, and you want to make sure that you're writing it this way instead. And this is the same thing as writing cos theta squared plus sine theta squared equals 1. However, this is the more simplified version. Okay, so trigonometric identities improves Unit 5, Lesson 5. So question 1, before you begin providing identities, it is important to understand the difference between the following words. Explain with the use of examples what each term means. So you've heard of expression and equation, and identity is the part that looks new to you. So expression is when you have what? No equal sign. Equation is when you have equal sign. And identity also has, they do have equal signs as well. So when you look at the three, because you have no equal sign for an expression, you're not able to solve for this. All you can do is simplify. So for example, if you have not y equals, but if you just have 2x plus 5, the thing is you can't solve for it. You might be tempted to, but you can only simplify. And it's already simplified because like terms have been collected already, and that's it. It stands as a binomial, and that's it. That's expression. Equation, on the other hand, is if you have 2x plus 5, and if it equals something like a 7. Well, what you can do is you could do BEDMAS backwards and try to solve for x. And so we can solve these. We can solve. And we get unique solutions. So for example, you might have 1 or 2 answers where this is true. That's an equation. So expression equations are familiar. Meanwhile, if you have, for example, 2x plus 5 minus 3x is equal to negative x plus 5. So for this, you can't solve for them since every value for x works. And you can prove them. So what I mean is, if you look at the left side of the equation, well, if you simplify that equals negative x plus 5. So if the left side equals right side, well, they're the same thing, really. And so you can't solve for it because it's saying one left side equals the other side, and all you can say is that therefore the left side and right side is equal, and therefore this statement must be true. So number 2 says, show that the following identities are true for any angle. So you got to make sure that you're using proper form. There's 2 proper forms that I'm going to introduce you to, which is by writing left side, right side, and you could draw these lines and work on them separately. And if the 2 sides equal, that means this is a true statement. It's a true identity. Meanwhile, you could also write it so that you write left side equals and your work, right side equals, and then your work, and then compare the 2. Those are the 2 appropriate ways of comparing. Otherwise, bad form, for example, is if you did tan theta is equal to sine theta divided by cos theta, and you kept kind of like writing your work down with the equal sign between each other and going through it, because although it looks like exactly the same as this version, this one assumes that this identity is already true before you start off, and so that's why it's not as good of a form. And so this is the acceptable way, or if you write the left side or right side separately. So trig identities can be difficult, okay? But there are some rules of thumbs that I try to remember, which is 1, try to work with primary trig ratios. And I'm even going to add that you're sometimes going to try to use the cos theta or sine theta if possible, but this isn't always the case, okay? This is just my rule of thumb that I try to follow, but sometimes I have to go back to tan theta as well. But we want to use the primary trig ratios and definitely not the secondary trig ratios. And also, honestly, with the trig, you basically don't know what you're doing, but you want to make sure that each step is true and you're not faking a step. There is such a thing called faking each line and make it seem like it's true, but it's really not. And so it's very important that you're able to identify what's going on. So one way you could approach this question, and you might approach it a little differently, is that, well, when we're looking at this as like a unit circle, I remember that tan theta is equal to y over x, and sine theta and cos theta can also be represented as y, x, and r, right? And so then we have, for sine theta, I have y over r, and I don't like to write the division sign over a fraction, and so sometimes I write the division sign separately like that, and cos theta is equal to x over r. When we do that, I want to multiply by its reciprocal, and so this is what I get. Okay, so at this point, I notice that the r's cancel out, and so I have y over x on the right side as well. And so therefore, I can state that therefore left side does equal the right side, and so then that suggests that my identity is true. For formality, the most accurate way to say this is since left side equals right side, therefore tan theta equals sine theta divided by cos theta is true. So it's a true identity. You'll often see, therefore, left side equals right side, and that implies that the identity is true. Okay, we have our left side and we have our right side. Drawing our t-chart and going from there. One very important thing as you go through these, it's one of the reasons why we draw the t-chart, we draw the line, is to not make it confused with the equation where we're often moving the numbers around to one side to the other, right? And that was totally acceptable. Although you have the same equal sign when we're proving an identity, I drew these lines as, and one reason is I can never move things around between these lines. It's like they do not know of each other. You have to treat it totally separately, like so, and separately, like so. So just make sure that the numbers are never, never, never going from one way to the other, okay? Treat it very separately. So I'm going to use the same strategy as the one before. Okay, let's see. We have sine squared plus cos squared theta equals 1. So a general approach is work with a more complicated version. So between the two, one is very simple. That means I want to work on this more complicated side. So let's start off. So this is a little tip I've added. So on the sine squared plus cos squared theta, that could be rewritten as y over r squared. Remember, this 2 implies that this whole thing is being squared. Plus, have x divided by r, bracket squared. So remember, I'm kind of treating it separately, and so this is my right side, and this is my left side, okay? And so I will have y squared plus r squared plus x squared over r squared. Recall that when you have the same denominators, you can combine the numerators and write it together. Because this is the same thing as me writing 2 over 3 plus 4 over 3. So I could have added the 2 and the 4 and kept the 3. And so here I have y squared plus x squared. Well, what do you remember about x squared plus y squared? Well, according to the Pythagorean theorem and the one about circles, we have the equation x squared plus y squared is equal to r squared. And so I can write r squared divided by r squared, and any number divided by itself is equal to 1. And at this point, I can say, therefore, left side is equal to right side, and so this identity is true. Number 3, the proofs to identities are not unique, hence it is important to write out what you do in each step, list some strategies to try when doing proofs. So, like I said before, we want to change all trig ratios into sine / cosine. So we got to recall some equations. And so first we have tan theta is equal to y over x, and therefore you have sine theta over cos theta. This is coming from the fact that since for a unit circle, you have that sine theta is equal to y over r, and if you're dealing with a unit circle, radius will be 1, and therefore sine theta is equal to just the y, right? And for cos theta, you would have x divided by r, and when dealing with a unit circle, this is x over 1, and therefore x. All right, and so this is all kind of coming together. Next, we have our reciprocal identities, which is the cosecant theta is equal to 1 over sine theta, and you've seen that before. You have secant theta divided by secant theta is equal to 1 over cos theta. And then you have cotangent theta is equal to 1 over tan theta. All these three are the reciprocal identities. And in brackets, I'll write secondary trig ratios. And it's basically coming from the fact that they're reciprocals, right? Meanwhile, for these two over here, they are coming from quotient identities, because you're using the fact that tan theta is based on y over x, and then you are filling in the information that you know for sine theta and cos theta. Let's keep going. So we have consider starting from the most complicated style, and I've had that written over there. We're just pulling it together, but those two are one of the most important. And then we have try factoring or expanding. You could try LCD or distribute denominator. And that's if you see a potential cancellation. Next, we have use sine squared theta plus cos squared theta is equal to 1. This is the Pythagorean identity. And you could rearrange it in different ways. So you could get the cos squared theta by itself by moving it to the other side. Or you could get the sine squared theta by itself. Okay, well, one of the reasons I brought up the formula page was I was getting a lot of these ones in these boxes, and I felt like it'd be more organized if you just had all the identities in one page, okay? So lastly, if you see binomials with sine theta or cos theta, but notice there's no squares, so without squares, then use the conjugates. Meaning you're going to try to use 1 minus cos theta or 1 plus cos theta. And so we have dealt with the first two examples, and the other 4 will probably make more sense as I go through more of these questions. So note that things that you need to watch out for, things you will lose marks within your communication is not explaining steps or skipping steps. For writing terms incorrectly, example cosine tan without theta. Because remember, those are the function names and we need to have it in terms of the input. Or just say cosine, sine, tangent, the full name maybe. Sine theta squared when you mean sine squared theta. Remember, those two mean different things. This one means that you have bracket sine theta squared. For incorrectly canceling or simplifying, moving terms over the equal sign. Remember how I said that was a big no-no? This is not wrong to do, however, the proofs in grade 11 are not particularly hard, and if terms are moved, proofs can become too simple. To have you well transition to grade 12 and future math courses, just keep that in mind when you're doing these proofs. Number 4A, prove the following. Sine theta plus cos theta divided by tan theta equals 1 divided by cos theta tan theta. So one thing I noticed about the two is both seem like they need to be simplified a little because they both look a little complicated. So first step that I'm going to do is try to get rid of that tan theta. Remember how I said that we want to get our terms in terms of sine theta or cos theta or the primary trig ratios including tan theta, but tan theta is also the one that we usually switch out of to get to sine / cos theta. So first step, I'm gonna have sine theta plus cos theta. Recall that tan theta is equal to sine theta divided by cos theta. So I'm going to work on the left side first. And actually, I do have to work on both sides just so that I know what I need to get it to simplify to. So I'm going to do the same thing on the other side. So 1 over cos theta times by sine theta divided by cos theta. Notice that those cancel out. And on the right side, I have 1 divided by sine theta. I do need to write down how I'm getting these. So first step, I use the quotient identity that says tan theta is equal to sine theta divided by cos theta. And then from here to here, I just simplified. So that is the right side. So I know that I want to try to get it to the right side as much as possible, get it to look like the right side as much as possible. And right side is kind of simplified as much as I can. So at this point, I know I don't want fraction over fraction. So I am going to change it so that I have sine theta plus cos theta. So I'm really multiplying it by the reciprocal. So I'm going to switch those two so that I have the reciprocal. And so the step I am doing is quotient identity for the first step. Followed by, I need to multiply by reciprocal. At this point, I notice that I need to figure out the LCD because this has a denominator of 1 and this one has a denominator of sine theta. And so I'm going to write LCD is sine theta, so I could combine the two fractions together. And so sine theta is my denominator. To get that term to have a denominator of sine theta, I need to multiply bottom by sine theta and also the top by sine theta, because what I do to one part of the fraction, I have to do to the other. And so I'm going to have sine squared theta, because I have 2 of them, plus cos theta times cos theta is equal to cos 2 theta. I remember that there is an identity where the 2 are equal to 1. And this is by Pythagorean identity. Pythagorean identity. And so I noticed that the two sides are equal, so I'll just do it the long way once. So since left side equals right side, therefore sine theta plus cos theta divided by tan theta equals 1 over cos theta tan theta is true. So that's my long way.